In this video, we're going to look at how using Tyk Operator, you're able to run GitOps enabled API management in Kubernetes. So I've just got a few slides and then there's a technical demonstration as well. So to kick things off, I thought it might be useful to just have a quick refresher on what API management's all about. It's when you expose APIs for others to consume, and they might be externally facing APIs. So perhaps you're working open banking, say, and you need to expose account and transaction APIs, but equally it could be internal microservices that you need to expose within your own organizational boundaries. Either way, API management enables us to enforce policies about who's allowed to use these APIs, establish security flows to authenticate and authorize permissible use, track who uses these APIs, and build a catalog of services that can be used to promote API usage and lay the foundation for effective governance. The Tyk API management solution is a full lifecycle API management solution. It's more than simply a gateway. It also comprises a control plane from which we can centrally manage and govern what might be API gateways that are distributed and used by multiple teams in different geographies around the globe. Within that control plane, we're able to configure who's able to use what APIs and with whatever rate limits and quotas that we need to enforce. We're able to configure things like protocol mediation and transformation between, say, XML and JSON to perform content-based routing. There's also an analytics dashboard, so administrators are able to go in and see how the APIs are being used and if there's any issues that need to be looked into. And there's a full version in a lifecycle management capability as well. There's also a developer portal that enables us to expose our APIs to the developer community and engage with that community, provide documentation that allows them to get up and running using those APIs quickly and effectively. The Tyk solution is essentially deployment agnostic, so you can run Tyk in your own infrastructure, and that might be, for example, on bare metal, say, or on virtual machines. It obviously supports containerization and can be run in Kubernetes. We do also provide a full SaaS service, Tyk Cloud, that enables our customers to let Tyk run and operate their API management infrastructure in their cloud provider of choosing in whichever region they like. And we also support a hybrid model within which Tyk will run and operate the control plane in Tyk Cloud on behalf of our customers, and our customers can run their gateways close to their services in their own infrastructure. So whilst we're talking about architecture, the idea of a decentralized microservices architecture within which developers should be working without dependencies on external systems or teams or processes. This might seem a little bit at odds with a centralized API management architecture, which at least traditionally was often implemented as tightly controlled shared infrastructure owned by either a platform team, say, or an integration team or some other API infrastructure teams. With an operator-led approach, many of what might seem apparent conflicts here are negated somewhat, and we'll see more of that in the demo. Getting into GitOps now, one of the principles of GitOps is that the system should be described declaratively. But what does declarative mean? Declarative is the what as opposed to the in the imperative model, which is the how. And this can be a little bit difficult to understand initially, I think. So if we think about this outside the context of software and use a restaurant example, In the imperative model, if I'm going to a restaurant with my partner, it might go something like, I see that table over there is empty. My wife and I are going to walk over and sit down. In the declarative model, that would look something like, table for two, please. So it's a slightly cheesy example, but it helped me. Moving on to the other principles of GitOps. So once we've described our desired system state declaratively, the next principle says that declarative system state should be version controlled in Git. And so with the declaration of your system stored in a version control system, you now have a single source of truth from which everything is derived and driven. Your apps can be easily then deployed and rolled back to and from Kubernetes. Once you have the declared system state version controlled in Git, the next step is to allow any changes to that state to be automatically applied to your system. And then finally, once the state of your system is declared and kept under version control, software agents are used to inform whenever reality doesn't match your expectation. So if you imagine deploying an application to production now, what actions actually need to occur? Typically, you're going to need to deploy not just the application itself and how many instances of that application, but you'll also need to deploy perhaps monitoring. Maybe you need to configure public DNS in Route 53, say, and then you'll need to configure your API manager to expose the application in a secure fashion, enabling MTLS perhaps, and enforcing some kind of authentication and rate limiting. So what Kubernetes allows you to do is orchestrate the deployment to all of these disconnected systems in concert using a single Kubernetes API. You provide it a declarative blueprint, and the operators or controllers within Kubernetes know how to interpret and action that blueprint. And so the alternative would be to do each of these actions imperatively and somehow coordinate the order yourself. It wouldn't be straightforward. Tyk Operator interacts with the Kubernetes API directly using custom resource definitions. The operator runs in Kubernetes, but actually the Tyk API management stack itself need not run in Kubernetes. You can use the operator to manage your Tyk API management solution on bare metal or even on Tyk Cloud. It doesn't have to be in Kubernetes. And I mentioned custom resource definitions there, so perhaps just a quick look at what they are. A CRD allows you to manage your custom objects and Kubernetes native objects exactly the same way through a single pane of glass. And that's it in terms of presentation. So we'll now move on to a technical demonstration and try to bring this to life. So to start the demonstration, I thought we'd have a quick look at how you publish and manage APIs in Tyk the traditional way using our control plane, Tyk dashboard. So in Tyk dashboard, I can publish a new API. I could import from OpenAPI spec if I wanted, or if it was a SOAP service from a WSDL. But let's just quickly go through manual wizard. We support RESTful services, obviously, but equally you can import and create SOAP services. And we also support GraphQL as well and that comes in two flavors. So it might be an upstream GraphQL service that you want to manage on Tyk in the same way that you might a RESTful service, by setting authentication and authorization rules, by setting rate limits and quotas. With GraphQL as well, you also get to do things like limit the query depth of a GraphQL query, and also control which fields are actually returned and made available to the consumers of the graph service. And then we've also got this universal data graph as well, which allows you to stitch together a variety of different upstream data sources and orchestrate and control that and present it as a single graph to your consumer. So think modern lightweight ESB, but we'll stick to publishing a RESTful service. I won't go through all of this. There's quite a lot of capability in here. So I'm just going to publish this API. We'll set the authentication mode to be keyless, but there's a bunch of other standard authentication modes that are all available out of the box, and all the kind of common expected modern security standards are supported on Tyk here, but we'll just leave that as authentication token. And then if I want to then control who has access to this API, I might create what's called a security policy. And so within that policy, I might select a number of APIs that I've published into my control plane. I'll just select the one. I can set rate limits, throttling rules, quotas. I'll just leave all of that as default. Just call that demo policy. And let's say that key is going to expire after a week. And create the policy. And then I could also issue a key that actually is associated with that policy. Actually, the way that normally works is that through a developer portal, a consumer, an app developer would request a key. But so that was just a quick look at what this looks like, doing this the traditional way, using the dashboard UI, the control plane of Tyk. Let's now have a look and see what this looks like using Tyk Operator and a declarative model. So let's just have a quick look at what we've actually got deployed currently. I'm running all of this on a single node of Minikube on my laptop. There are a number of namespaces that I've already created. So if I did a Tyk in the Tyk namespace, what we've actually got is the Tyk API management infrastructure itself. So the gateway, the control plane. There's also some dependencies. So there's a Redis cache and a MongoDB and a Tyk pump, which basically allows us to send analytics generated as requests flow through the Tyk gateway. The pump then sends that analytics data off to the observability platform of your choice. In this case, I'm just sending everything to MongoDB to be viewed in the dashboard. But we do support many third-party observability platforms, so Elasticsearch, Prometheus, Splunk, etc. So that's the Tyk namespace. And then we have also a Tyk Operator namespace, and within which this is the Tyk Operator itself that's going to allow us to work with Tyk in this declarative GitOps way that I described. Right now, there is already a Tyk API. That's a HTTP bin API that I would be able to call on this URL, and it would route to an upstream HTTP bin service. So let's create something new. So I'll flip over to my IDE now. And what we've got is a manifest that describes a Kubernetes deployment and service for an ATM locator. So let's actually apply that into our cluster. There's nothing Tyk in there at the moment. So if I do a K apply -f, and it's gone off and it's created the deployment and the service. So if I have a look at the pods in my default namespace, I'll see, as well as that HTTP bin thing that was already there, we've now got an ATM locator pod that's currently creating. And that's now running. And so, but we've got this new application that's up and running, but currently we don't have any way to actually access that. So if I look at the services that I've currently got, and we'll note that they're all of type cluster IP, which means basically speaking, we're able to access these applications only from within the cluster itself. And what we want to do is actually make our ATM locator service available outside the cluster. So let's go ahead and do that. And this is where the operator comes in. So back to my IDE. And so in the same context, in the same tool that I, as a developer, I'm already using to package up my microservice, I'm able to use that same tool to configure Tyk to expose this thing. So I don't need to go off and learn how to use Tyk dashboard. I'm using an environment that's already familiar to me. So I can come in here, and because I've made this IDE aware of the Tyk operator custom resource definitions, you'll see that I've got auto completion capabilities. It knows that because I've selected the API version tyk.tyk.io, it knows that I have these custom resource definitions available. And so I will select from this enumeration an API definition. Next, let's just provide some metadata. So I'll select a name and I will call that ATM locator. And then spec, and let's just auto-complete that. Wrong, and give that a name. So we'll call this ATM locator C. Protocol will be HTTPS, and then the target URL will be the service that's already running, and that was running in my default cluster. So that should look something like ATM locator dot default.svc. I believe it was running on port 8000. Okay, we want this to be available on Tyk at /ATM locator, and we want to strip the listen path when we make the call from the Tyk proxy to the upstream ATM locator service. A couple of other things that I've forgotten to add there. So initially I'm going to set this to be keyless, so I won't need to provide any kind of API key or other authentication token. And let's say that it's also active. And I think that's everything. Okay, so let's try and apply that now. Okay, apply ATM locator.yaml. And so the deployment is unchanged, the service is unchanged, but we've now got this new thing, a Tyk API definition called ATM locator. So if I now get what Tyk APIs are available, and I'll see there's this new thing called ATM locator that's available on this listen path. So let's actually try and hit that. So if I, first of all, can do that in another window. Okay, see, I want the external IP address of the Tyk gateway. Which we've got here. So let's try and call that. HTTPS. /ATM locator /2/ATM. And that's come back with a couple of ATMs in Tokyo. So that's brilliant. Right now, and an ATM locator is probably a good candidate for an open API, but let's imagine this was something that's perhaps got payment data in there or PII data. Let's imagine this is something we want to secure. So back to the IDE, and again, within the same tool, I can extend this manifest and I can configure a security policy. So the API version will be the same as we just set. The kind this time will be security policy, metadata. Let's just call that, give that the name ATM locator. See, by the way, what I omitted to do was show in the dashboard that new thing should have been created. The ATM locator proxy that we used Tyk Operator to publish is now shown in our dashboard along with all the other APIs. So back to my IDE, let's complete the configuration of the security policy. So it's kind security policy. I'm now going to provide which APIs I want to be made available under this policy. So let's just configure the ATM locator service that we just created that was running in the default namespace and was, I didn't implement any versioning, so it's the default version. Let's say we want to make this active immediately. ATM locator policy. And then within here, let's imagine we want to set a rate limit that says 10 requests per second. So rate 10 per, actually, let's make it 60 seconds. Okay, that's the security policy. So if I now apply that, same again. This time we should see that the deployment remains unchanged, the service remains unchanged, the API definition remains unchanged, but we've got a new security policy. Query that by saying kubectl get Tyk policies, and there we go. we've got a new policy called ATM locator proxy. If I try and hit the service as I did previously, I should now, interesting. Oh, I omitted to actually update my API. So I've got a security policy, but actually the API definition is still configured as keyless. So let's just update that. Use standard auth, true. Apply that again. And now if I try and hit that, I should be denied access. And we need to provide an API key. So let me actually create a key in the UI. And again, this would typically be something that a developer would request from the developer portal. The end result would be the same. A key would be created in the dashboard. So I'll select the policy that I just created using Tyk Operator, create key, copy that key ID, and then back to my command line and pass in an authorization header this time. Hopefully that should work. So yeah, we're now able to hit that API again by providing a valid key. So one last thing I wanted to add to my API definition. So we've secured it. We can also do some kind of more interesting things such as cache, safe requests typically on the Tyk gateway. So I'll set a cache timeout. I'll enable the cache, and I will say let's cache all safe requests. Okay, and I think that's everything. So reapply that definition. And now if we curl that, we should see, let's just switch that, put the verbose option on, try and hit that again. So hit it once. The second request should actually be served up from the Tyk gateway directly using the cache, and we can see the Tyk cached response header is set, indicating that this was actually served up from the cache. So we've just seen how using Tyk Operator we can declaratively describe our system state and apply that to our Kubernetes cluster. But what we didn't see was actually how this works with having the source of truth in version control in Git. And so I just wanted to quickly show how we can use a tool like ArgoCD to work in concert with Tyk Operator and provide true GitOps enabled API management. So let me just clear up quickly what we just created. So let's delete Tyk. Policies. What did I call that policy? Proxy. Delete that. Delete the API. Let's also delete the deployment and just do it all from scratch. VC/ATM locator. And then I'll also, no, I think that's everything. Right, so let's strip this back as well. And let's have this updated definition to version control. Let's just immediately push that. Okay, so back to my command line. We've only got the original HTTP bin. The ATM locator doesn't currently exist. So this time I'm going to use ArgoCD to actually interact with version control with GitHub and to essentially keep my cluster in sync with whatever I have committed into GitHub. So first of all, let's create the app. And if I do an ArgoCD app get ATM locator, and I can see that that's not currently synced. So let's just go ahead and sync it. I think by default it syncs every 3 minutes, something like that. So that's now synced. And if we go ahead and do a get pull default namespace, we'll see there's an ATM locator pod and an ATM locator service, still no Tyk APIs. Oh, sorry, no ATM locator, Tyk API. So back to my IDE. And if I reapply that, and I'll just actually, for now, I'll just make this keyless. So we'll get rid of the policy. Use keyless true. Commit that. And so version control now has a new version of this manifest that also includes the Tyk API definition, and that is now not in sync with my cluster. And so as I mentioned, I think the default sync policy is something like 3 minutes. So I'm going to have to actually force the sync. Otherwise, we're just going to have to sit looking at my screen for 3 minutes. So let's just force that sync. This would happen automatically eventually. And so that should now, and it looks like it has, created an API definition. So if I get Tyk APIs, we can see there's a new thing that's popped up. If I come here, I should see that the ATM locator proxy has been recreated. And we should be able to hit that again. Shouldn't need to pass any kind of authentication token. And there we go. So that's everything I wanted to show you. Thanks for your time.